Hi, so today we're going to be talking about confidence intervals. And confidence intervals are very simple. They are basically just a way of knowing how accurate our sample is according to the population. So when we do an experiment, we will often take a sample. So we have a sample, and we want to use the sample to infer to the population. Well, in order to actually know if we can do that or how accurate we are in doing that, we use what's known as a confidence interval. So a confidence interval, as the name implies, tells us how confident we actually are that our sample is reflective of the population. And to be more technical, our confidence interval tells us how likely we are that the true population's average falls within our sample. And the way that we do this is we first will obtain a sample, and we'll have a sample average. And let's say in this case we're going to be looking at the heights of men. So let me pull out an example here. So if we want to look at the heights of men, we will say that we get 40 some men, and we'll say that our our sample average that we got was 175 centimeters. And this was obtained from a sample of 40 men. So n equals 40. And we'll say that our standard deviation in this case is going to be 20 centimeters. So our standard deviation S is going to be 20 centimeters. Now, how confident are we that this sample reflects the total population? Well, the confidence interval, or CI, is given by the formula x bar, or sample average, plus or minus the sample's standard deviation times a z-score used in the confidence. So this is our confidence score divided by the square root of our sample size. Now the z-score actually is pulled from the normal distribution, and it's not too important, but we usually have a table for this, and if we want to say that we want to have a 95% chance of the true population average falling within this sample size, then we will go to the confidence interval table and we'll find the value for 95%, and we'll see that it's actually 1.96, and we'll just plug that in for z. So in this example, we are going to be dealing with a average of 175 centimeters. So here we'll say that our confidence interval is 175 centimeters plus or minus our standard deviation of 20 centimeters times 1.96, because we want to be 95% confident that the population average falls within this interval. And then we'll divide that by our sample size of n equals 4. So 40 square root. And the values we'll obtain from this, we can actually use Desmos for this. So we'll say that what is 175 minus 1.96 times 20 divided by the square root of 40. Well, this is actually 168.8. So we'll say that this is going to be 168.8. And then the upper end of this will be 175 plus 1.96 times 20 divided by the square root of 40. And this will actually be 181.8 0.2. We're going to be rounding to the first decimal point. And here, our confidence interval is from 168.8 centimeters to 181.2 centimeters. And what this is saying is that we are 95% confident that the true population average, our mu value, falls within 95% confident that mu falls within our confidence interval. Or in other words, we are 95% confident that the inequality 168.8 less than mu, which is less than 181.2, is true. So if we actually drew this out on a number line, we would say that here our x bar is going to be 175 centimeters, and the lower end of this will be 168.8, and the upper end will be 181.2. And here, this is actually our confidence interval, and all it's saying is that we are 95% sure that the actual true average is going to be somewhere within this confidence interval. And that's pretty much it. Thanks for watching, and see you next time.